you see me now? Okay, all right. Last week Dave and I started making our AR-10 .308 caliber lowers, and we used a little mini mill. And you know, the mini mill is a great little machine, but it uses these dial readouts to set the X, Y, and Z axis. And they're fine except for a thing called backlash. All of the little moving parts in there are run by screw drives. And with those screw drives, you always have a little backlash. When you go one way and you want to crank back and go the other way, it takes a little bit for the gears to mesh, and that throws your dials off. Due to that backlash, now that's not that bad a problem. It's the way it is. You can figure them out without a lot of sweat. But you have to do a lot of figuring when you want to do other things too. So I decided here, well, about a year ago, I got these DROs, Digital Readouts they call them. And these are by a company called iGaging. They're about, oh, I don't know, 30, 40 bucks each. They're not very expensive. And with these little babies, these little puppies, you have a digital readout to a 1/1000th of an inch, and it doesn't care about any screw backlash, because when your head starts going, or your table starts going the other way, the readout, which is magnetically driven from a bar, measurement kind of bar on there, like with your calipers, why that baby will just kick right in and the dial will move. During the backlash, it doesn't move at all. Makes it nice, makes it much easier to do the machining for me, as far as I'm concerned. We were on a fellow's friend's Bridgeport here the other day. That's one of the big commercial rigs that he put in his garage. And he had that set up with what they call CNC, which is driven by a program, computer program. It actually has motors on all the axes and moves the axis according to a plan, a program that you put in it. So we're not going to be quite that fancy. We won't be a full CNC machine, but at least we'll have the digital readouts, which will be a big aid, make things go faster. And that's the idea. Why be bored with all this messing around with them? Adding and subtracting by 1/1000th of an inch here or there. It takes about 5/6,000th of an inch for the backlash to kick in, and you have to account for that. Okay, well, I'm going to show you the mill, show you what we're up to here, and what I'm doing to mount these readouts. I'm going to modify this mill. I finally decided, after Dave left with his lower. I still have mine to go, and I'm going to put these on before I do it. I've got to do some machining on the mill itself. Got to mount these things, and I'll do that with my drills and taps, and if I have to make a couple brackets, I'll make some brackets. I finished up the Z-axis, that's the up and down axis, and I want to make a little video of that one right now, just to send this over to Dave so he can see where we're at. And he might get excited about making another one again then, so we'll see how that goes. Anyway, some of you others might be interested in this too. It's something to do, nice hobby to play with. What I really want to do is make some steam engines with this little baby before I'm finished. And this will be real nice for doing that. Miniature steam engines are a lot of fun. Okay, well, let's move on now. About a year or so ago, I guess a couple years almost now, I do a lot of work out here in the garage on my automobiles. My 56 Ford Thunderbird, a little bit on the newer ones, the Maserati and the Corvette, but there are only a few days a year you can do it, otherwise it's too hot in the summer and it's too cold in the winter. So I said, well, you know, I've got most of the time I had to do this stuff is in the winter. In the summer I'd like to be out riding my motorcycles and driving my cars and chasing up down highways and going to the beer joints. And well, I don't go to the beer joints so much anymore, but anyway, you get the idea. So, okay, here I put this heater in a couple years ago. And that's nice, because I don't care if it gets 30 below outside now. I can go over here to this computer-driven thermostat digital thermostat that I've got, I can bring that temperature right up to 72 degrees. Average mean temperature at Tegucigalpa, Honduras. And that makes it a lot more convenient to work out here in the winter. So I've got the drill press over here. I use that a lot. Not only doing machine work, but doing just general messing around out here. You always have to drill holes, it seems like. I've got it set up now for outside measurements for a nice easy fit for a number 6 screw. Used a lot of number 6 screws in this project, so I just leave it set up till I'm finished. A couple of vices there. I use those to hold parts on the table. And of course a bigger vise there for bigger work, which we don't use much for this one. Over here in the main workbench for the mill, we've got the mill itself, and I'll show you a little more about that in detail in a minute. A lot of lighting there. The old poor eyes need a lot of lighting to read those dials. Hopefully once I get the DROs in, I can cut some of that expensive lighting, especially this halogen stuff here. And here we've got a few of the some of the supporting equipment and tools. Tap and die, one of 3 or 4 tap and die sets. There's a nice drill set there. That's every drill size, all the way from very, 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 very teensy tiny. Maybe you can see that here on this end a little bit. Those are some tiny drill bits if you want to build watches or something, I guess. And all the way up to a pretty large one. I think the largest one is, I don't know, maybe 5/16 or so. And then over here, I got our mini lathe, which is part of the machine shop. Got him covered up now. We're not using him for this project, but that's another mini machine from a little company called, that one I think came from Harbor Freight, but it's the same thing that you get from a company called Little Machine Shop. A Little Machine Shop sells all sorts of tools and equipment to support these mini machines, they call them. And I get a real bang out of going through the catalogs and ordering things from time to time. There's a tap and a tap guide to keep you from breaking the taps off in the holes, particularly the smaller taps. So we've got all sorts of things from a professional company called Shars, as well as Little Machine Shop. There are some clamps, a lot of clamps for clamping different things to the tables. And up here we got cutting fluid, grease, WD-40. No shop is complete without WD-40. Mills, transfer punches, bits. Hydrogen peroxide, we use that once in a while for this and that. Over here are a couple of indicator holders and some dial indicators. Maybe you can see the dial indicator on that conventional holder. Use those to do such things as tram the mill and the lathe, even the drill press. I've trammed that to make sure everything is square with everything else. That's one of the biggest things you need to be sure of if you're going to do any machining. Doesn't do you any good if you're off a few degrees on one of the planes, and whatever you make is not going to work probably. So you want to be pretty exact, and you have to make sure your machines are squared up before your work's sure not going to be squared up. All right, well, this is the mill. The milling machine is pretty versatile piece of equipment here, and you can do small projects with this. It's got, I think, a 9-inch travel on the Z-axis, which is up and down, and 13 to 14 inches on the X-axis, which is left and right. Maybe about 8 inches, 7 to 8 inches on the Y-axis, which goes back and forth from the back to the front. Over here, this is the modification that I just made to put the DRO on. All right, and there it is. Let's see, this is the slider. The slider is hooked to the head, so as the head moves, I'll show you that here. Pop this out, it's in the slow mode now. Pop this out, we'll lower down, and you can see that the slider, which is the sensor, just moving up and down that rule, magnetic rule. Up here is a close-up of the brackets I built to mount it. We have a mount on the top and on the bottom, and then the head moves along that slider. So we always know exactly where we're at in relation to where we start. So we'll bring it back up, and I'll show you the dial. The dial indicator works. Now this is on high speed right now. We'll put her on lower speed, you get a little better feel for it. This is, see if we can focus that. I didn't want to focus very well. You can maybe see those little gradations though. They're at 1/1000th of an inch. And as you move the head up and down, this will tell you where you're at. This is where that backlash business comes in. You go one way, then when you start to go back, it'll be just a few thousandths before the screw will engage the head, and it'll bring her back the other way. So I call it slop. That's what I call it. They call it backlash, which I guess is what it really is. And you'll notice over here on the DRO, I don't have it mounted yet, but this has a digital readout, which is very nice, and I think we can get that pretty well focused here. Okay, and as we move up and down here, and you can see it read out in 1/1000ths of an inch. Let's go to the top. We'll hit the 0 set. So now we're 0. We say that we're 0'd as we go down. Tells us how far we're going. 147 thousandths, 258 thousandths, 258.5 actually, so it's down to 10 thousandths. So it's, we'll read 1/1000th, which is plenty of precision for what I build. I don't have to be any more accurate than that. But you notice that as I turn it, it's not really very fine. It's just jumping a bit. Well, let's put it in the fine mode. Bye. Okay, now we've got the clutch engaged, and we've got control on the fine dial here. And you see as I move it down, the fine dial, that we're cranking a little slower. Now if we go down here and look at our, okay, now we'll go on 83.5, 84, had a lot finer control. 86. And I'm kind of at an angle here, so. But now you'll notice as we're at 188. Notice it as we go back. See, that's you see the slop in there? As I move this back, this dial moves, which is not a good deal. We're still on 188 over here though. Slopping that back and forth. Now we'll start moving it back up. Actually, this is the extent of the slop, which is quite a bit. Okay, there. It's quite a bit, so that's a problem. But as we go back now, okay, now I'm getting some engagement going. I'm going back towards 0 now. You can see that the DRO is reading out to go the other way. So that's always exact as to where we're at on the positioning. That's nice. That way we're always know precisely to within 1/1000th of an inch where we are. That's on the Z-axis, the up and down axis. Then we're going to do the X-axis. We'll do that next. So to go this way and back again, we'll have another DRO readout. And then we have the Y-axis, which is the table in and out. You can see again the slop there going from one way to the other. Okay, so that's what we're doing. We're mounting this DRO. We'll put a little, we'll build ourselves a bracket to put these up here. This way it'll be okay. And I'm going to make this into a little movie to send it over to Davey. As long as I'm doing that, since I have to put it on YouTube, I'll put it out there so everybody else can see it too. Why not? I haven't put a movie out for a while, so I'll do this one. All right. That's it in a nutshell. From the Dick and Dave Machine Shop. Over and out.